So in this video, we're going to take a look at how to work out the equation of a straight line, and that's going to be given the line itself, or draw a line if we're given the equation. So first of all, before we get started on those examples, let's just take a look at what a typical straight line equation looks like. And you may have seen this before, but it always has the same format. So an example of a straight line could be y equals 3x plus 2, or y equals 8x minus 5, or y equals minus 7x plus 3. And even if it doesn't look quite like this, it could be rearranged so that it could look like this. So this format is known as y equals mx plus c, because there is always some number m in front of the x, look, okay, and there is always some number c, even if it's negative, some number c, okay, on the end. So this m and this c help us to work out the steepness of the line, where the line is positioned on the graph. So how are we going to get then from our line on our equation, on our diagram, to an expression like this, a formula for that particular line? Right. Well, we need to find two things. So the first thing we need to find, and let's do both of these examples at the same time, right, is we need to find where the line crosses that y-axis. So you can see in both of these that we have it crossing at 2. Now, we call this the c number, or the c in the y equals mx plus c. So in both of these examples, we can see that c is 2. It won't always be 2, but in these it is. Okay, now then let's have a look and find the next thing, which is the gradient, right? Now the gradient is like the m number. So to do that, what we're going to do is we're going to pick any 2 points. So let's just pick one there, look, and one there. It doesn't matter where they are, as long as they're on sort of set coordinate numbers. And we're going to work out the change in y between the two, so going like straight up between the two, and the change in x. Okay, so in both of those cases it's 2, and we're going to, or I should say though, to be honest, we're going down 2 rather than up perhaps. So I might do minus 2 there. And so our value, and we're going to call it an m for gradient, is going to be the change in y divided by change in x, and that in this case is minus 1. On that other example, let's just take a look and do the same thing again. Any 2 numbers, I mean, let's just pick there, look, and there. We've gone down 3, so the change in y is like minus 3, across 1. So our value for m is going to be minus 3 over 1. Change in y divided by change in x, and that is minus 3. Okay, so we can see how to get those numbers. Now, all we're going to do then to work out the equation of the line is we're going to write out that same format we saw earlier. Y is equal to, now we put the gradient in next, minus 1 x plus 2. And that c goes in there. Look, the gradient goes in there. Now, I suppose minus 1 is the same as minus x, so we might write this as y equals minus x plus 2, but that's the principle, okay? In this second example, we would have y is equal to minus 3 lots of x plus 2. And again, the minus 3, that gradient, that steepness goes in front of the x. Okay, that's our m, and our number on the end is the 2, okay? And that is how we get the y equals mx plus c. We need to remember this is the gradient. This is known as the y-intercept. Okay, so let's take a look, right? Okay, and come and look at it from a different angle now. So if we're given the gradient, let's just make sure we've really got this clear in our mind. Sorry, given the equation, what's that gradient? What's that intercept? So in this first example, well, if we have y equals 2x plus 7, the gradient is 2. It's that number there, look, okay? If we wanted the y-intercept, then that is positive 7, or just 7, okay? It's the number on the end. Now, if I'm trying to write out that equation, I know what that gradient and y-intercept are, it's quite simple to do because I can have y is equal to that gradient x plus that intercept. So it's going to be 8x minus 2 in this case. Let's just skip one and come back to that, and we'll write these other ones out. Y equals 7x minus 5. Y equals minus 3x plus 2. Y equals minus 5x minus 2. So if we're given that gradient, given that y-intercept, this is very straightforward to write the equation. Now, there is one tricky one in there that I have so far avoided, but we've got to be very careful about it because in this case, there's something a bit off with the equation. It's not quite in that right format because we usually see it with the number on its own after the x. So this is equivalent to minus 3x plus 8. I've just swapped around those numbers. And from there, now I can see that gradient, right? That gradient is not 8, it's minus 3, but the y-intercept is 8. Now, let's go at it from the opposite perspective now. What about if we had that equation and we wanted to draw the line? Now, I don't have a ruler here, so forgive my lack of straightness in my lines, but we'll give this a go. So let's start off, look, with y equals x plus 1. So if I have just an x, it's like there's a 1 in there, look, 1x plus 1. So let's draw this out. So first of all, we identify the y-intercept, which is 1. So I'm going to mark that on my diagram, right? Okay, my y-intercept is 1. It's the number after the gradient. Now, my gradient here, look, is 1. So that means my change in y over my change in x was 1, right? So try to recreate that. Think about it this way. If I go one step to the right, and then I go one step up, I would have achieved 1 divided by 1 is 1, right? So that's going to be a point on my line, okay? Think of it as every time I go 1 across, this number, this gradient is however far I go up. So another point would be there, and another point there, and so on and so on. And once you've got a few of them, I'm sure you could join these up in a straight line through any graph. So there we go. Okay, so this is the line, y equals x plus 1. Right, let's take a look at the next one. So in this case, we have, let's write it over here, y equals 1 minus x. Well, first of all, I'm going to write that in the correct order, minus x plus 1. It's the same thing. Now, once I've got that, again, I can mark that y-intercept. And again, look, it's 1. So I'm going to mark my cross there at the point 1. Now, this time, the gradient is like a minus 1 being there. So this time, if I go 1 across, I got to go 1 down. That gradient is telling me how far I go down. So 1 across, 1 down, 1 across, 1 down. That's what this is showing me. Once we've got a few of these, we can then start to join these up with a straight line and continue this through the graph. And we've done another line here, haven't we? Okay, this is the line. Let's just write it down. Y equals minus x plus 1. Okay, we've got 2 more to go, and this time we're really going to see what that gradient's doing. So this time, exactly the same as last time, we are crossing at plus 1. Let's mark that point there. Okay, and this time, though, the gradient is 2. So every time I go 1 across, I'm going to need to go 2 up. So 1 across, 2 up would be here. 1 across, 2 up is there. 1 across, 2 up, and so on. I could go backwards in the same direction if I want to mark some more points. But I've got my markings for my straight line. Let's join those up. And we can see the difference with that gradient being 2. Okay, it's making it steeper, isn't it? Right, so this is y equals 2x plus 1. Final one we've got to do, look, okay, is 3x plus 1. So again, we're marking the plus 1 first because that was our intercept. Our gradient is 3. So from that point, if I go 1 across and 3 up, and 3 up, I'm going to get some points. I go 1 back and 3 down and another 3 down. So now I can join these up. And there is my grey line, y equals 3x plus 1. So the y-intercept is sort of helping us to understand where we start, and that gradient is helping us to then draw the line. So let's just make up a couple more examples to really make sure we've got this. What about if I do y equals a negative this time? Negative 2x plus 4. Okay, so the plus 4 tells me where to start. I'm going to be starting at 4 on the y-axis. My gradient's minus 2, so I go 1 across, and then, of course, it's 2 down, because it's minus 1 across, 2 down, 1 across, 2 down, and so on. And I can go back in the same direction if I want to as well. Join these up. Excuse not having a ruler here, look. But you get the idea. That is the line y equals minus 2x plus 4. Now, what's great about this is we can even do this for fractions. So let's have a look at something that looks a little bit complicated, but actually isn't. So what if I said y equals 2/3 of x minus 2? Well, to start with, I'm going to definitely mark that minus 2. I can absolutely see clearly that my y-intercept is minus 2. Now, remember that the change in y, right, divided by the change in x is that gradient. So you could imagine a change of y of 2 and a change of x of 3. The numerator is the change in y, the denominator is the change in x. So to find the next point on a fraction, I could go 2 up and 3 across, because I've got 2 there, look, and 3 there. 2 up, 3 across. Could go back 3 and down 2 to get more points as well. So if I then join these up, we get that fractional line, y equals 2/3 of x minus 2. I almost think the fractions are easier than the whole numbers in these cases. Okay, I hope that helps you to understand how to plot a line given an equation, and also to find an equation given the line itself.